Hi, this is Steve Liu. I'm here again to talk about. Really want to talk about some of the topics that ISED brought up that were common issues. I thought they'd be very interesting for the industry to get clarifications on, and some things I can go a little deeper on. And I'd be glad to have conversations about any of these topics. And I was actually thinking the first thing to focus on. I'll just dive right in. I was going to talk about the thing about the Bluetooth for FCC versus ISED. And then if you stick around to the end of the video, I actually made a visual that'll help make more clear, understand why the FCC and the ISED, how they differ. That way it's easy to visualize and see, understand why it was raised. All right, so let's jump into it. Okay, so I said this is their slide with the common measurement errors. And the thing I'm going to focus on for today is this first one. Bluetooth exemptions from routine evaluation for ISED are not harmonized with FCC. Therefore, care must be taken when applying these exemptions. And KDB 447498 shall not be used for determining exemptions. And the way Jason shared about this, it seemed like a lot of people were doing this. They didn't know the nuances between the Canadian and the U.S. exemption requirements. And so this video, I aim to make that even more clear and to help us with that. So just to introduce this a little bit, assuming antennas here, the top of a smartphone, I just gave that as an example. There's a distance that's associated with, the proximity to the head or the body and with the antenna. So now if you can see here, regardless of where the antenna is located inside the product, the housing and the product itself is touching with the human head or human ear here. So the distance here is actually 0. So these kind of things have in our mind as we're going to go deep into some of the requirements and formulas today. All right, so starting with FCC, I thought I'd bring this up. This one, we can look it on the website. If you want me to do a video on how you can look up these KDBs or the FCC IDs, I'll do one later. But you can look these up on the FCC website easily. So the publication 447498 in section 431 explains about how you exclude SAR testing. And there's a combination of power and distance and frequency that'll help you determine whether something is excluded. So what do I mean by power? So the FCC says here, the maximum conducted output power of the RF channel requiring evaluation adjusted for tune-up tolerance. So what does that all mean? I have an example here of a Bluetooth power table, and this is public information, nothing secret. But there's various Bluetooth modes, whether it's EDR, LE, or 1 meg or 2 meg, whatever. And in a product like a smartphone, there might be multiple antennas. There might be 2 antennas. And why would they have 2 antennas? It's to have different diversity. So for example, in the picture I showed before, maybe one antenna is on the top of this, and maybe there's one on the bottom. So maybe on the bottom is a little more free. It can reach, you'll get better throughput or whatever because it's not being dampened by being near a person's head or body. So they have these spatial diversity techniques to improve the performance of these antennas. So they might have 2 antennas. Wi-Fi, it's pretty common to have that. And it might be a dual thing, which means both might be transmitting at the same time. Maybe it's just optimal, you get more throughput, whatever it is. But anyways, about the powers, what nominal means is the target power that the manufacturer sets for mass production. And what maximum means is that it's including the upper tolerances, including factory variances, temperature, what have you. So they might set it at 17.5. There might be units that are 17.6, 17.4, and they're saying that with all the different variations that can happen in mass production, it won't exceed 18.5. So what the FCC has required for SAR testing and output powers is clarifying what these are and the tolerances so that in the end, the SAR values are scaled up to not the nominal, but the maximum. So basically, it covers any single thing that might be produced in mass production. The SAR levels that will be exempted or not exempted or tested, the SAR levels will cover that, those edge cases. So they always want to cover worst case. So that's what the powers is. And the second criteria is distance. So the second highlight says the smallest distance from the antenna and radiating structures or outer surface of the device. And then the rest of it here, to any part of the body or extremity or user or bystander. And that's why I brought this diagram, whether it's head or the body or the hand, regardless of where the antenna is inside the product, it's the outer housing and how far it touches the human head or body. So that is the smallest distance from the antenna radiating structures. That's what that means. And this final thing I want to bring up is the third highlight, which is a statement of justification and compliance must be included in the equipment approval in lieu of the SAR report. And this is important because Bluetooth might be low power, maybe it is exempt, but you can't just file the SAR reports, the usual SAR reports, or no SAR report because it's exempt. And it's clear here that the lab or somebody or the manufacturer or the TCB has to have some sort of exhibit justifying with equations that this product is indeed exempt from full SAR testing. Otherwise, SAR testing is required. So really have to include whether it's an exclusion formula to justify why you don't have to test it, or include the test report with the test results. And down here is the formula to help you determine what the exclusion is. And it's a little messy. And for me, it's hard to read because it's kind of this line wrap type thing. So for me, I like the traditional formulas, and I'll show us that later to help understand it and see that more clearly. So just to give us first an overview about what the smallest distance means. When in SAR labs, they have these things called phantoms, which are just empty cavities, and it simulates a human body or a human hand. And why it's called a phantom is because you fill it with this liquid that simulates the dielectric constants of the human head or body with a certain fluid. So the SAR lab fills those fluids based on the target temperatures or target frequencies are being measured. And depending on the exposure condition, and in this case, it's the body-worn accessory, which is one of the setups for covering a situation where you have a smartphone, you put on a belt clip, you put on your belt, and the manufacturer in the manual says use belt clips that will give you a spacing at least 1 centimeter away or 10 millimeters away. So that's the test that has to be performed to prove that in such conditions that the SAR is passing. So this is the body-worn accessory SAR setup for 10 millimeter. And it says here the test separation distance is determined by the smallest distance between the outer surface of the device and the user. So this clearly shows that. Likewise, if it's 5 millimeter distance and the manufacturer's advertising that, that's going to show up as 5 millimeter. So that's kind of what that looks like. And then, sorry, this red should not be out there. It should be back on the phone. But for hand, it's obviously placed on the hand, so that the real distance is 0 millimeters. Or maybe, if this was a head phantom, that's also 0 millimeters, like the previous illustration. But for the formula, don't use 0 millimeters because it's going to generate an undefined result. And I'll show you why later. So here's the formula in a formula form, and you can see why I mentioned about the distance. So instead of writing this big word wrap here, I put this in a formula. I think it's much easier to understand as an engineer. The distance on the denominator. So obviously, if the distance is 0 millimeter, this thing's gonna be huge, and it'll never be excluded. So the FCC knew that, and they said, well, any distances 5 millimeters or less, put in the number 5 in here, even though the test distance might be 0. So that's something maybe it's not so intuitive, but make sure you do that. So you're putting in the power here in linear units, in watts, milliwatts, including the upper tolerance with the distance in millimeters. Make sure those units are correct. Don't mix up watts and meters or whatever, centimeters. And then the frequency in gigahertz. So you got to remember to include all those zeros, include the numbers, not include the zeros. So take the square root of that, and if that's equal to or below 3.0, then you can exclude the SAR testing for 1 gram for the head and the body worn and the hotspot. And the same formula is used for the 10 gram extremity, but the number here is 7.5. I don't know how they came up with that, but I think they came up with different scenarios, different situations. They took real things and determined these formulas are most conservative and good for the public. Now, how does the FCC US compare to Canada? I just want to show a table from RSS-102 Table 1. And here, if you look at 2450 megahertz in frequency, for 5 millimeters, the exemption level is 4 milliwatts, which means if your product is 5 milliwatts, you have to test it for SAR if you want to certify this in Canada. If that product is to be used 5 millimeters or less. So a watch, a phone, those sort of things. But at a distance of 10 millimeter, so for example, for hotspot mode, usually the required test is at 10 millimeter. If there's a hotspot mode, you're allowed to have the Bluetooth or Wi-Fi, whatever it is. If it's below 7 milliwatts, then you can skip the SAR test. I mean, that's a small power, and basically no Bluetooth or Wi-Fi would fall under those exclusions. So probably for other technologies. But on the other hand, for FCC, there's a more lenient threshold, and I'll show that in the graph next. Now, here's the bonus here, is this graph. I put this together. I put a couple of distances here just to help us see this. So typically 0, head, hand, maybe 5 or 10 millimeters might be used for a hotspot, depending on the manufacturer and the size of the device. Smaller devices less than 9.5 centimeters have to be tested at 5 millimeters. But larger devices like a phablet or whatever, those hotspots can be measured at a distance of 10 millimeter. And then some manufacturers have 15 millimeters warnings in their manuals. So to get into this and to understand this, so 10 milliwatts, doing the calculations, is equivalent to 10 dBm. And 50 milliwatts, on the other hand, that one is 17 dBm, which might be more typical of some unlicensed products. So ISED Canada, the exemptions, when I put the tables in here, it is so low. So you cannot exempt Bluetooth unless you're going to cut the power this low. And the FCC exemption is, it's not too high, but it's here. It's different. Clearly it's different. And you can imagine if I have a product hovering up here, let's say a Bluetooth product hovering up here, power levels around 30 dBm, it doesn't matter what distance. I mean, you have to go farther maybe to get it exempt, but you're going to have to test the Bluetooth. But I think where people get confused is if this product is maybe, I don't know, let's say used 5 millimeters and it's 8 milliwatts. It's exempt for FCC, but it's not exempt for ISED Canada because ISED Canada has limits 4 milliwatts. Really important because you'll get dinged when you file for your application trying to get on the REL and you try to double dip the FCC exemption report, maybe your lab kind of just generically made or whatever it is, not realizing that there's a nuance between Canada and US. And they brought up for a reason because any products between these two lines, they're not exempt for ISED Canada. You have to test it. So you have to create a separate FCC exemption report for products in between these lines, and you have to actually do the SAR test for those in Canada. And at that point, you might as well just have ask your SAR lab to just measure FCC and ISED and make one single SAR report, and then especially for products that have simultaneous transmission, you'll get the benefit of having a lower SAR level. And usually the SAR levels are not too high, but you still have to show the calculations if you don't test the SAR. So this is the bonus question I was eager to share. I created this graph. I'm a visual person. It helped me to be able to really kind of see the differences. And once you see the graph, you're like, oh, okay, yeah, FCC is different from Canada, and I got to make sure that's right, especially for manufacturers that have really low power levels. So I hope that's helpful. This video is just about the Bluetooth exemptions and clarifying and understanding the reasons why one would be exempt or not and what the filing requirements are. So I plan to do maybe a couple more videos, some of the common issues, but hope you liked it. Talk to you later.